Hello everyone, today we are going to talk about white box testing. Like we said, we have black box testing techniques and we also have white box testing techniques. We have explained earlier the black box testing techniques and we said that these are the techniques in which we don't know anything about the internal structure of our system. We just provide some inputs and wait for the output. For example, if this is a calculator that adds numbers, I add 2 plus 3 and I wait for the output, which is 5. I don't look at the function or the coding which performed this operation. On the other hand, white box testing provides input to the system, but it looks at the internal structure of the system. We perform the same operation, for example, 2 plus 3, which is 5, and we begin to look at the code that performs this operation. Okay, we begin to design our test cases based on the scenarios that the code is going to work in. That's why some people call it architectural based testing or structural. Why? Because you test the architecture or the structure of your system. White box testing is mostly used by developers. Okay, any developer who is testing his code must understand white box testing. When he is performing unit testing or component testing, he must use the white box techniques on his code. And it is also used by testers in critical systems, okay? And also we can say sometimes in agile modes. Okay, so if we are performing or developing a system that is safety critical, we must ensure that all the paths inside our code is tested correctly. That's why we may ask the tester to perform white box testing. So whether you are a developer or tester, this section might be helpful for you, okay? And also in agile testing, we have something which is called team cross-functionality or cross-functional team. What is it? It means that the team merges their functions, okay? The tester sometimes he develops things and the developer sometimes tests things. That's why the tester might perform unit testing, and in this case he is going to test the code. But there is an important thing. If you are going to perform unit testing or white box testing on any code, you must be efficient and experienced in the language that this code is written in. So if this code is written in C, you must be familiar with C. If it is written in Java, you must be familiar with Java. We will begin in the next videos to explain the white box techniques. We have statement coverage, decision coverage, condition coverage, path coverage, MCDC, and other techniques that we will talk about each one of them in a separate video and begin to solve some examples on it. Thank you and see you in the next video. I'm going to talk about the first white box technique that we have, which is statement coverage. Like its name states, statement coverage tries to cover the statements in our code. So what are the statements first? The statement is any line of code. The line of code that we have is called a statement. Our goal in statement coverage is to cover all the statements inside our code. If we cover all the statements by test cases, this is called 100% statement coverage. Okay, so is this a good technique or a bad technique? Okay, if you are going to perform testing in an easy way and a fast way, this is a good technique. But honestly, this is not the best technique that you are going to use on your code. And that will be explained when we talk about other techniques. When you know about decision coverage, path coverage, you will explain or you will understand that statement coverage is not a very effective technique. But first, we must understand it and then go to more advanced techniques. Okay, so how can we calculate the statement coverage inside our code? Okay, we have the code, we have some test cases, and we need to know the percentage of statement coverage. Like we said, if we cover all the statements, this is called 100% statement coverage. But what if we didn't achieve 100% statement coverage? What is the percentage of statement coverage? In this case, we have a formula. We begin to divide the number of statements tested divided by total number of statements in our code. So for example, if my code contains 4 statements and my test case passes through the first 2 statements, this is called 50% statement coverage. Okay, if it passes through 3, this is 75, 3 divided by 4. If it passes through the 4, this is called 100 statement coverage. Okay, so let's have a very simple example. This is a very simple example that doesn't happen in real life situations. In next videos, we will begin to solve more advanced examples. Here he says, if x is greater than 7, print hello. So how do we achieve 100% statement coverage on this code? What are the inputs that we must provide so that we get 100% statement coverage? Okay, our goal here is to provide 100% statement coverage with the least number of test cases. Okay, 1 or 2 or 3, the least number that can be achieved. So let's think of a number that will achieve 100% statement coverage. We might say x equals to 8. Let's trace our code. Is 8 greater than 7? Here x is equals to 8. Yes. So I ask the question and the answer is yes, so I will print hello. So this is 100% statement coverage. Okay, let's think about another test case. If x, for example, equals to 5. So here 5. Is 5 greater than 7? No. So he will pass through this line of code, but he will not print hello. Okay, so here he passed through 1 out of 2, which is 50% statement coverage. This is the difference. And of course, it is better to achieve 100% statement coverage. This is another example. If x equals 3, print hey, else print never mind. So here, if we go x equals to 3, is x equals to 3? Yes, I will print hey. Here, one test case will not achieve 100% statement coverage ever. Why? Because this is my question and it has two paths. X equals 3 and x does not equal to 3. Okay, so I must have at least 2 test cases. Okay, I can to achieve 100% statement coverage here with one test case. It must be 2. So here I will say x equals to 5. Is 5 equals to 3? No. So he will go to the else and print never mind. So these 2 test cases achieved 100% statement coverage. And this gives us a rule, okay? If your code contains else, code, if it contains else inside it, you can't achieve 100% statement coverage with one test case. You can achieve it by 2, 3, or more, like we will see inside next examples. Thank you and see you in the next video. Let's now have a simple example on statement coverage. If day equals Monday, then statement A, else statement B, and if. So this is our first if statement. The second if statement, if day equals Tuesday, then statement C and if. So here, our day has many choices. It might be Monday, it might be any other day, and it might be Tuesday. So one might think, okay, we have 3 test cases. The first, the day is Monday. The second is any other day, let's say Saturday, and the third is Tuesday. Do these 3 test cases perform 100% statement coverage? The answer is yes. But is this the best way to perform statement coverage? Like we always say, we need to perform 100% statement coverage with the least number of test cases. So here's the answer is no. We can have a less number of test cases to cover this code. Here, the else statement B. It means that in this statement, we can have any day of the week other than Monday, okay? So what if we think of only 2 test cases? The first has the day of Monday and the second in which the day is Tuesday. So here we have only 2 test cases. So in the first test case, if today equals Monday, then statement A, okay, else statement B. Let's take Tuesday and pass through the code using it. Is Tuesday equals Monday? No. So this will go through the else, okay? It will go through else and perform statement B. Then, if today equals Tuesday, is today Tuesday? Yes. Then it will perform statement C and end the code. So this is more efficient only using 2 test cases. Let's perform statement coverage on this piece of code. So here our code says start do until b equals c. What is the meaning of do until? He means that do this code, okay, execute this code as long as b is not equal to c. If b is equal to c, this code will not be executed. So do until is equal to, for example, if not. Okay, it is similar to it. It is not the same exactly, but it is similar to it. Okay, so here I will do this code as long as b is not equal to c. So what is my code? If today is equals Monday, set a equals 1, else if today equals Wednesday, a equals 2 and b equals c. End if, so this if will end here. And we will begin another if statement if b is smaller than c, b equals b plus 1. So how many test cases will be needed for statement coverage, and what are the inputs that will be used in these test cases? Okay, so first, in order to execute this code, I must make b not equal to c, so that I go inside this code, okay? Here I have an if statement, and this if statement has two decision outcomes. Today equals Monday and today equals Wednesday. So I must have a test case in which today equals Monday. This is the first test case, and I must have another test case in which today equals Wednesday. If I have these two test cases and they have the condition that b is not equal to c, then I will be covering this piece of code, okay? Then we have if b is smaller than c. Well, I need another test case, a third test case, to execute this part of code? No. Why? Because I can cover this part of code inside any of these two test cases. So here I have test case 1 and test case 2. Let's write them on the right hand. For example, we have the first test case, b is not equal to c, okay? And today equals Monday. So here I pass through this path. Okay, then the second test case, b is not equal to c and today equals Wednesday. Okay, and any one of the two test cases, I will make b smaller than c, not b not equal to c. It might be greater than c or smaller than c. No, I will make it smaller than c. Okay, so in this case, let's trace our first test case. b is smaller than c. Start, okay, do until b equals c. b is not equal to c, so we will go through the code. If today equals Monday, today equals Monday, set a equals 1, okay? Else if today equals Wednesday, today is not equal to Wednesday, so he will continue his code, end if. Then, is b smaller than c? Yes. Therefore, b equals b plus 1, end if, and end the loop, okay? The second test case, b is not equal to c, smaller or greater, then he will go through the code. Today equals Monday, no, he will go in the else, set a equals 2, and b equals c, and when b is equal to c, okay, so this condition has been met. Here, b equals to c, so he will not continue his code, he will stop here. He will not go through this if statement. And that's why I chose the first test case to make b smaller than c. And in this case, we covered 100% statement coverage of our code with only 2 test cases. In this example, we have a variable that is called quantity. If this variable is greater than or equal to 20, the discount will be 5%. If this variable, the quantity, is greater than or equal to 100, the discount will be 10%. So you as a customer will buy some items from the store. If you buy more than or equal to 20 items, you will get a 5% discount. If you buy more than or equal to 100 items, you will get a 10% discount. So how many test cases will be required in order to achieve 100% statement coverage? Any person who thinks about this example might say, okay, we have 2 if statements, so I will have two test cases. In the first one, I will think of a value that is greater than 20. In the second one, I will think of a value that's greater than 100. So for example, he might think of the values 25 and 105. This is an example. So 25 will pass through the first if statement and 105 will pass through the second if statement. But what if we think of only one test case? What if we want to achieve 100% statement coverage with only one test case? So I might think of another or a new test case. If the input, for example, is 105, let's go through the code with this input and trace it and see, does it achieve 100% statement coverage or not? So 105, is it greater than or equal to 20? Yes. So I would apply the first discount. Then I will ask, is 105 greater than 100? Yes. So I will apply the 10% discount, and this is 100% statement coverage. So here I needed only one test case to achieve 100% statement coverage, even though my code contains two if statements. Let's try to solve this example using statement coverage. Here we have a natural language, we don't have a code. Pick up and read the newspaper, look at TV. If you find a good program, watch it. Otherwise, continue reading. If you find a crossword, then solve it. Here we have the first if statement with its else statement. So this is the first if statement, and this is the else. Otherwise means else. So here you might find a good program on the TV and watch it, or you might continue reading your newspaper. Then while you are reading your newspaper, if you find a crossword, then you are going to solve it. So here, if we want to perform statement coverage, we will need only two test cases. In the first test case, I will find a good program on the TV and I will watch it. The second test case, I will not find a good program on the TV, so I will continue reading, and then I will find a good crossword in the newspaper and I will solve it. So here we need only two test cases to achieve 100% statement coverage. The first for the program on the TV and the other for all the activities inside my newspaper. This example, he says input A and B. This means that the user will provide input to the system, which is A and B. Then the variable C will contain the values of A plus B. If C is greater than 100, print it's done. How do we test this code? We want to cover all the statements. We want to make sure that each statement of this code is covered at least one time. So we can use this test case, which has the values of A equals 50 and B equals 60. Let's try this. C equals A plus B. This means that C equals 50 plus 60. Is C greater than 100? Yes, it is 110. Then we will print it's done. Let's try this code in Python. So we write A equals input, enter first number, which means that we will get an input from the user by showing the message enter first number to him, and this value which the user will enter is going to be stored in the variable A. The same will be done with B, so B equals input, enter second number. Okay, then C equals A plus B. If C is greater than 100, print it's done. Let's try this. Okay, save. Enter first number, I will say 50, and second number is 60. He printed it's done. Then our code is going well like we expected. Note that if you are using Python 3, you need to write integer before this input, okay, to convert it into an integer
because it takes the number as a string. This is a difference between Python 2 and Python 3, and this is why we need statement coverage, okay? If we are using Python 3 and we don't know this problem, if we write this code in this way, it will run as a string. So to make this point clear, we opened Python 3 online, okay? This is the same code. Imagine that I am a developer who is used to use Python 2, and this is his first time using Python 3. When I write this code and I press run, he asks me to enter my first number. I will say, okay, my code is going well. There are no errors, no warnings. Then I will not test this code more thoroughly. But this is wrong. I have to try the input. So when I write 50 and 60, the same inputs that I provided to Python 2, the program gives me error. Okay, it is type error, not supported between instances of string and integer. So I have to change this into integer and this also into integer. So I write the first number 50 and the second number 60, and he printed it's done. This is the value of statement coverage, okay? I would not have known that this is an issue without executing the code and trying each statement of this code, because if there is a type error, I will know it using statement coverage. Let's try another example. The same example, input A and B, C equals A plus B. If C is greater than 100, print it's done. If A is greater than 50, print it's pending. End if. We can use two test cases, A equals 40 and B equals 70. The sum of them is greater than 100, then I will print it's done. And the other test case, I will make A greater than 50 and B equals 50, then I print it's pending. Let's try this code in Python. So I will add if A is greater than 50, print